8.3 refers itself to is about something called the discriminant. It discriminates between how many solutions an equation, a quadratic, has. We start off with the quadratic equation with this solution. X is negative b plus or minus root b squared minus 4ac over 2a. Now this complicated looking thing inside the square root, b squared minus 4ac, is called the discriminant because it discriminates the cases of two solutions, one solution, or no solution. If b squared minus 4ac is positive, then this is a number plus or minus two numbers. It gives you two solutions, two real roots. If b squared minus 4ac is 0, then square root of 0 is 0. This term just goes away, and we're left with minus b over 2a, a single root like this, called a double root. Now, imagine if you take a quadratic, graph of a quadratic, which will be this U-shaped form called a parabola. Here, it equals 0 at 2 points. Here, we lift it up so that it just touches the graph, the horizontal axis, at 1 point, so a single root. Called a double root because it's as if these two roots had merged together into one. And if b squared minus 4ac is less than 0, then we have a square root of a negative number, which is not a real number. So we get two complex roots, no real roots. Here it's as if the parabola lifted off the line entirely and just disappeared, and the roots just disappeared, at least from the real axis. If b squared minus 4ac is a square of a rational number, then you get rational roots. If it's not, then you have irrational roots. So. All right, so here we have examples of what kind of roots and how many. 4 squared x squared minus 4x plus 1. You look at the discriminant, negative 4 squared minus 4 times 1 is a 0, a single repeated root. X squared, 5x squared plus x plus 2, the discriminant is 1 squared minus 4 times 5 times 2 is a negative 39. Negative, so these are complex roots. And 39 is not a complete square, it is not a square of a whole number, so these are two irrational complex roots. 2 times x minus 3 equals 20. Expand it, 2x squared minus 3x minus 20 is 0. And the discriminant is negative 3 squared minus 4 times 2 times negative 20. It's 169, which is a square of 13. So these are rational roots and real roots. 3x squared minus 10 is 0. Well, b is 0, a is 3, c is negative 10. Discriminant is 0, minus 4 times 3 times negative 10 is 120, which is positive, so you have real roots, but it's not a square, so these are irrational. So it's two irrational real roots. There are some equations which are really basically quadratics in disguise. So here's x to the fourth plus 9x squared plus 18 equals 0. Now, really, it's a quartic, a fourth degree equation. But a fourth power is the square of a square. So really, we can rewrite this as the square of x squared plus 19 times x squared plus 18 equals 0. So we can solve this as a quadratic. X squared minus 18 times x squared plus 1 is 0. So either this factor is 0 and x squared is negative 18, or this factor is 0 and x squared is negative 1. And then taking square roots again, x is plus or minus I root 3, 2, I times 3 root 2. We're taking square roots here. X is plus or minus I. So these are the four solutions to this quartic. 2x minus root x equals 3. Oh boy, or root x, how annoying. Well, let's rewrite this x as the square of root x. So twice root x squared minus 1 root x minus 3 equals 0. This is a quadratic in root x. So we solve it. Root x equals, use the quadratic formula. B is negative 1, so negative 1 goes here and here. A is 2, so 2 goes here and here. C is negative 3, so negative 3 goes here. And after some arithmetic, you get 1 plus or minus root 25 over 4. That's root x is 1 plus or minus 5 fourths, or 6 fourths, or 1. So X is 6/4 squared or 1 squared. That's 9/4 or 1. And 3 halves. Oh, let me double check this. 1 fails, 3/4 works, or 3 halves, 9/4 works. I gotta erase this. This is a mistake. I gotta change this in the canvas. It's X equals 3 9/4. 8, 3, 3. Okay, I made a mistake, so I get honked. Right. So not 1, it's 9/4 is the solution. And here we have this rather gnarly looking thing where 2x plus 1 is the expression inside a quadratic. So we can solve for 2x plus 1. B is -7 here and here. A is 2 here and here. C is 6 goes here. And after working it out, 2x plus 1 is 6 plus or minus root 1 over 4. That's 8/4 or 6/4 or 2 or 3 halves. And then we just can transpose the 1 and divide by 2. So x is 2 plus 1 over 2, or x is 3 halves minus 1 over 2. And x is 3 halves minus 1 over 2. Bit of arithmetic. X is 1/2, or x is 1/4. That's solutions to this. This one, it's again a quadratic in disguise because a 2/3 power is the square of a 1/2 power, 1/3 power. So it's x to the 3rd squared plus y to the 3rd squared plus y to the 3rd minus 20 equals 0. This we can factor. Y to the 3rd plus 5 times y to the 3rd minus 4th equals 0. So therefore this is factor is 0, making y to the 3rd equal -5. Or this factor is 0, making y to the 3rd equals 4. And then we solve by cubing both sides. So y equals -5 cubed, or y equals 4 cubed. So y equals -125, or y equals 64. These solve this equation. Here's y to the -1, 2 times y to the -1 minus 20 equals 0. Well, okay, y to the -2 is the square of y to the -1, so another quadratic in disguise. And this factors y to the -1 plus 5 times y to the -1 minus 4 is 0. So, okay. So the 5 and 4 makes 1. 5 times -4 is -20. Okay, so one of these factors is 0. So y to the -1 plus 5 is 0, making y to the -1 be -5. Or y to the -1 minus 4 is 0, making y to the -1 be 4. Then take reciprocals. Y is -5 to the -1, or y is 4 to the -1, which means that y is -1/5, or y is 1/4. And these solve this equation. Okay, looks like we're done here.